So good morning and welcome. My name is Richard Tomkinson. As David said, I'm the Principal Infrastructure Architect for Cloudten. Today I'm talking about using AWS as a secure, scalable outbound gateway. Now, this is actually a published case study with AWS that we've just had published last week. It's for one of our largest customers, iCare. So for those who don't know, iCare is the New South Wales state government insurer. They do every work cover policy in New South Wales. They insure such landmarks as the Sydney Harbour Bridge and the Opera House. They are one of Australia's largest insurance companies in terms of revenue and assets insured. And about 3 years ago, they adopted an all-in cloud strategy and run the bulk of their infrastructure inside AWS. So one of the first questions here is why would we want to use AWS as an outbound gateway? So what tends to happen in large traditional networks is you get a lot of capacity constraints. If you've got regional sites, like say in an MPLS network, you can get bottlenecks between those sites. You might have issues with legacy hardware, might need to be maintained, licenses renewed, and you just might not want to manage that much physical infrastructure anymore. Two key benefits which AWS give us there is that we have real-time redundancy in the fact that we've got 3 availability zones or data centers laid out across Sydney. And that provides real-time redundancy through there. And another key thing is that inbound data transfer is free. So this particular solution that we developed for iCare had a number of requirements. So that was redundant high-speed connections into AWS from their corporate network. They wanted commercial-grade security appliances in there, so like next-generation firewall, IPS, web application firewall. They wanted it to be highly available and scalable across their data centers, so in essence, real-time disaster recovery. They wanted everything to be deployed automatically, whether it's the infrastructure deployment, the configuration, or any updates in terms of security rules. They wanted to use this eventually to be the default outbound route out from their corporate network. So not just a proxied, but to route completely through the environment. So this is just a high-level diagram. The iCare have over 1,000 staff, and this environment was to enable their staff to use emailing services, like through Office 365, all their SaaS applications, so things like Salesforce, and for general internet access for their staff. Now, first of all, connectivity. So Direct Connect is an AWS service that allows a dedicated private network connection between a number of locations around Australia. There are facilities in Sydney, Melbourne, Canberra, and Perth. And we can provision links from a variety of sizes, all the way down to 50 megabytes up to 10 gigabytes. They can be provided by AWS themselves or a variety of network service partners. For security infrastructure, we used the Sophos UTM. So the Sophos UTM stands for Unified Threat Management. It contains a number of security devices. So on the network protection front, we've got next-generation firewalls, IPS, SSL and IPsec VPNs, and then we've got the web protection modules. They have things like web application firewalls. We can also do email scanning and sandboxing if we want to. Now, there are 2 key components of the Sophos UTM. One we call the Queen. You can think of that as the centralized administration console. So we connect to that. You can either do it by GUI-based or CLI or API-driven configuration. And that's what stores all our configuration. Now, it stores all that config into an S3 bucket. So that means that we've got all that configuration stored centrally. We also run it inside what's called, it's an auto-scaling group, but we call it self-healing because it's one and only ever one. So what happens there is when we have an instance failure, it will completely rebuild itself and pull its latest configuration down from S3. So on the other side, we've got worker nodes. So these are the servers which actually process the traffic. So they're going to filter things from a firewall and IPS point of view. They exist in an auto-scaling group and can go from, in this case, from 3 to 9, because you can configure a minimum and maximum scaling point. right? And then it will scale across 3 availability zones, up and down. So it's triggered on CPU. So if what tends to happen is, like say at lunchtime when it's busy and lots of people are using the internet, we might grow out to 6 servers, and then it will scale back down to 3, and it will just destroy them and build them. And it builds itself again from S3. Now, to explain in greater detail how this works, so if we're on the Queen and we want to make some configuration updates, do some firewall rule changes, for example, that gets written to S3. At the same time, we post an SNS message to a topic, okay, and these are all core AWS services. Now, the worker nodes are subscribers to that topic. So as soon as that Queen posts that message to the topic, those workers are notified and they pull that configuration down from S3. Now, everything was built using CloudFormations. So CloudFormations is AWS's configuration as code service where we can write repeatable, consistent templates to deploy our infrastructure out. So in this case, there are 3 separate stacks which we ran in sequence. Okay, so the first one, it will build all the core network infrastructure, the VPCs and subnets across 3 data centers, the security group and ACL rules around that, and routing tables. And then is the core security stack. So that configures all our CloudTrail, which does all our auditing. So everything is completely auditable in this environment. We know who's done what, when, and where. Right? Config, which is a similar service where we can track config changes over time. Log filters for logging, and VPC flow logs, which is essentially kind of like our firewall rule traffic inside the VPC itself. Right? We also put a couple of bells and whistles on top of that. CIS benchmark reporting. So we have Lambda jobs which run through. They check the security groups against a certain number of rules. If someone's opened up a rule that shouldn't be done, they're notified of it via email. The security team will be notified straight away. So then there's the Sophos stack itself. So this is provided by Sophos. This will build out the entire Queen worker scenario. It's configurable, how many you want, your SNS topics, where do you want the alerts to go to. It's a really highly configurable template they give you, easy to use. In our case, we tweaked it a little bit to scale across 3 data centers rather than 2, and that sits on top. Okay. So there are a number of connecting services that iCare wanted to feed into. So they wanted to use Active Directory as their authentication mechanism. So obviously they've got a large Active Directory. They wanted to use single sign-on. So all the users on the internal network, they log on to their standard operating environment, they log in with their AD credentials, and then they want to surf the internet, all right? But they don't want to be logging into everything every time. So this allows for SSO to pass through a token so that all users are authenticated and tracked in the log so we can see who's surfing what and when. And we can use group policy to say, say, marketing might be able to get to Facebook, but your general population, you can block it. So we can use category-based proxy rules based on Active Directory groups, and that's what we do here. So we also plug into ServiceNow via API calls. So that allows us to not just trigger on infrastructure alerts within either the Sophos or AWS itself, but we can raise more fine-grained control. So we can write our own APIs to raise tickets to the appropriate queues if anything goes wrong within this infrastructure. iCare use Splunk as their main logging tool and scene. So we can ingest things like firewall rules, proxy logs, all that traffic will get logged into Splunk centrally. And because we've got an auto-scaling environment where we can lose servers at any time, failure in this environment is a given, because when we scale up and scale down, we can't guarantee which server is going to go down, and we don't care because everything is stored centrally. So Nagios was the monitoring tool that was used. Equally, we could use like a Dynatrace or a New Relic, but in this case, we used Nagios. Now, the big issue here is routing. So if we use AWS as a proxied service where we terminate inside and then re-establish, we don't have a problem. But there's a few key differences within AWS about networking that we need to be aware of. So essentially, layer 2 is obfuscated inside AWS. So it's no good changing a routing table on an individual host. It just won't work. You can do it, but it will have no effect. You can't target an IP address in a route table. You must target an AWS, either ENI or a gateway. It has to be an AWS resource. And we don't allow a gateway to set a next hop. Basically, you target the gateway, but the gateway does not know where to go after that. You need to target something inside that VPC to get out of it. Now, AWS call this transitive peering. So in this example, where we have 3 VPCs, and both A and C appeared to B, A cannot directly route to C. It would have to go to a point inside B. We have another concept called edge-to-edge routing, and this is more similar to the scenario that we faced. So you've got a corporate data center on the left, your direct connect or a VPN connection into a VPC, which is peered to a third. It's not going to work. All right? Now, in our scenario, that means that will not work for non-proxied traffic. So there are 2 solutions to this. Okay? One is called an OGW, an Outbound Gateway. So this is part of the core Sophos UTM solution now. So what an Outbound Gateway does, it's another EC2 instance where you can deploy it inside VPCs which are peered, and it will create a GRE tunnel between those 2 endpoints. So what we can do here, if we deploy OGWs in 3 different locations, and I've got an instance that sits in here, then I can target an address, I can put my routing table, route directly to him through this guy, okay? And then that tunnel, that mesh tunnel exists, and I've kind of got around that transitive peering scenario. Now, for on-premise to get out, okay, direct connects also have the issue, a similar issue to transitive peering, whereas if you try and target an address at the other end of the direct connect, which is not directly inside that VPC, the direct connect itself will drop it. So we need to then have another meshed VPN between your on-premises kit and AWS. And for this, we used the Cisco Csrs, so the Cisco Cloud Service Routers. Now, what they are is they are another virtual appliance. You can get them from the AWS Marketplace, pay again, on, like the UTMs, they're available in the Marketplace, BYOL or on-demand licensing. All right? They are completely compatible with existing Cisco gear. They do run in multiple cloud environments, run over BGP, and they create an IPsec mesh VPN. So in this scenario, we have our on-premises corporate network. So what will happen there is we'll set default routes, we'll do all our additional networking on the internal network and tell everyone to go out through an on-prem gateway. The GRE tunnels, which are configured between your Cisco routers on-prem and the CSRs, they pass that traffic through and then they'll forward that traffic through the Sophos UTMs. All right? So the traffic is encrypted, B, it's filtered through the firewall, so boxes in terms of security, and we've achieved our goals. So just to revisit, our redundant high-speed connections, we fixed up with multiple redundant direct connects from multiple locations. Our next-gen firewall, proxy, and SSL VPN, we used the Sophos UTM solution. For high availability scaling and self-healing, we used auto-scaling groups and ELBs. All build and configuration was done through cloud formations. We used SNS and S3 buckets so that the whole thing could be rebuilt at will in different environments. The default outbound route we used Cisco CSR for, and by the end, so it took us about, from inception to POC, one of the key drivers for this project was because of constraints on the internal network, a number of business critical projects were being delayed. So this had to be done quickly. So from the design and POC, it took about 6 weeks. So we were pumping about 100 or 200 test users out of this environment in 6 weeks, and within 3 months, 1,000 people were cut over to go out through this environment. Okay, so that's the gist of the talk. I'll just give a quick overview who Cloudten is. So we're an advanced AWS consulting partner. We are based out of Sydney, but we do have presences in Canberra, Melbourne, and Brisbane, and Singapore as well. We are the only consulting partner in ANZ to have both the government and security competencies from AWS. We're ISO 27001 certified, and we specialize in the design, delivery, and support of a multitude of cloud solutions and DevOps focused.